We talked a bit about our graphic workstation. Now let's move into the realm of audio and video editing. Audio and video editing share a lot of similar features when we're talking about graphical editing, where we're using a lot of processor power, we're using a lot of memory. So we want to make sure that we're keeping that high-end processor that we talked about with at least 3.2 gigahertz speed, 6 cores. We want to allow at least an 8 megabit cache, and we want to have at least 8 gigabits of RAM, higher if greater of DDR2 or DDR3. We want to have our high-end video card placed in there for the different audio or video or different video components that we'll need to display on our screen, and using our different video editing and video rendering. Specifically for audio and video editing, away from graphical editing, there's a few components that we need to take a look at. The first of them is going to be our specialized audio card. Comes in handy when we're looking for better quality rates on our sound. We're going to be looking for something that's at least 24-bit, 192 kilohertz or better. This will allow us to have better sound quality and better sound sampling when we're taking samples from the audio that we're editing, and we're piping that through our sound system that we have set up or the headphones that we have on, and we're making sure that that sound quality is good before we put it into production. Now, in addition to giving us specialized audio output, we also have specialized audio cards for our PCIe slots that allow specialized audio input, whether this be through our MIDI ports for our musical devices. We may run into a situation where we're recording directly from those MIDI devices, and we want to make sure that we have those available ports on our computer. All of this, our specialized audio, we're going to prefer using our PCI Extend slot for these. Additionally, with our audio and video editing workstation, we want to look at a specialized graphics card. Now, when we're talking about our specialized video or specialized graphics, we're talking about something that's going to be very fast, have a very powerful graphical processing unit. Now, this is because when we're editing this video, we're going to have buffering rates. We're going to have time that the computer is trying to load that video and spool it up so that we can edit it and work with it. And the lower end our graphics card is, it's going to take a lot longer, and it's going to make editing that video not only a lot more time consuming, but possibly a bit more frustrating than if we have our specialized video card. In addition to having our fastest GPU possible, we also want to make sure that we're getting a video card that we can plug into some really good displays, some high-end displays to sample that video and make sure that it's high quality and we don't have any distortion. So we're going to look for video cards with HDMI ports or DVI ports. We want to avoid VGA if possible, because our HDMI and our DVI are both digital, and they're going to give us a bit better output quality than our standard VGA would. The rest of our specifications for our specialized video card are a bit similar to our graphics card. We're also looking for a card with at least 2 gigabits of GPU RAM, and we may want this card to actually also support 3D rendering and 3D graphics with our, with our DirectX 11 or our OpenGL. Before we get this out of the way to make room for some of our next components, we have our specialized audio and we have our specialized video, and both of these are very critical components when we're doing, obviously, our audio-video editing. Now let's talk about our hard drive. When we were working with our graphic computer, hard drive wasn't as big of an issue because we have opportunity for external storage. Graphic files may be big, but when we're moving into the realm of audio and video, we're getting into files that are extremely big. High definition video and audio moved around and edited and saved requires a lot of space to save that information, a lot of space to save that work and work with it, especially because we're working with all of that in its raw format. We haven't compressed it yet and made it into something that's quite a bit smaller. So we want a very large and very fast hard drive. We're talking about something that's at least 1 terabyte, at least. We want to move into realms at least possibly where we're getting RAID arrays set up with even more space if necessary, external hard drives, which can be up to 3 terabytes. But the more that of our hard drive space that we can get inside of our computer, the more saving space that we have actually inside of our case allows us for a lot faster read and write times than if we have that out somewhere on our network or somewhere on an external device. I say 1 terabyte, but that's really sort of our very low base level. If we're working with a lot of audio and video editing, we may need hard disk drives that are even larger, 3 terabyte drives, multiple 3 terabyte drives, depending on how much editing and how much saving is actually going on. It's a bit easier to quantify our fast speeds. When we're looking at our hard drives, we're talking about different speeds for our rotations per minute. These rotations per minute for the hard disks allow for faster read and write times depending on what type of disk we're running at. Standard hard drives, a lot of times we'll see run at rotations per minute of about 7,200, but we're working with high-end audio and video editing where we're pulling that information and saving a lot of the time. So we want to look at hard drives with rotation per minute of 10,000, even up to 15,000 rotations per minute, rotations per second. 7,200 rotations per second is standard, but we want to be looking at hard drives that are possibly 10,000 to 15,000 rotations per second for our increased read-write time. Our 15,000 rotation per second drives are going to obviously be more expensive for the same amount of space than 10,000, but depending on your situation, they may be worth the investment. When we are setting up our computer, it also may be worthwhile for us to invest in a solid state drive, an SSD, for loading our operating system and our programs onto. Solid state drives are extremely expensive for the same amount of space that even a 15,000 rotations per second hard drive would have. A 1 terabyte, 15,000 rotation per second our internal hard drive would be massively reduced price than a 1 terabyte solid state drive. So when we're talking about solid state drives, we're not so much talking about using these for our large storage volume as we are talking about using these for loading our operating system and our programs from. This allows us to load these programs and load our operating system a lot faster, and by having these separate containers, our hard disk drive for our actual projects and our solid state drive for our actual programs and operating systems, by keeping these two distinct and two separate, it may help us with reducing the clutter, basically. We don't have all those projects on the same drive where we're loading our operating system from and loading our programs from, and additionally we have a much faster loading of the operating system and the programs. These solid state drives don't need a lot of space for loading the operating system and the programs. Typically, you can find these in sizes such as 32 gigabit drives. And again, that may be all you need just for the solid state drive. But if you do invest in that for the operating system, you definitely do need an additional very large hard drive, at least one, for your projects and your other information. Now let's talk a bit about our displays. Our dual displays allows us to have our video running on one screen and we have our editing on the other. Dual displays is going to pair a lot with the type of video card we have. If we don't have a video card that doesn't support the dual displays, then we're not going to have the opportunity to use them. So we want to check that out when we're getting our video card, and when we're purchasing the dual displays themselves, we also want to make sure that we get displays that are high quality displays that can support a large color range and most appropriately matched with the type of video card we have. If we have DVI or HDMI coming out of our video card, we don't want to downgrade that to 2 VGA displays. That really defeats the purpose of having the DVI video card. We're not getting that full resolution. We're not getting all of that color range that we have with the DVI or with the HDMI. So we want to make sure that we have our high-end displays and we want to have our HDMI or DVI ports. Our displays obviously can range in different sizes. What sizes are most appropriate for your particular situation just really depend on your personal preference. Some people like really long large displays, and some people like smaller square displays. Studies have shown that certain size displays are appropriate for different types of people. And when you get to display areas that are too large, you're really reducing productivity because you're spending more time looking around your displays to find information than you really are working on that information. So keep your displays large, give yourself a lot of space to work with, but don't give too much space where you're spending all your time looking for your mouse cursor and not enough time actually editing the audio and video. Just as a recap, for our audio video editing station, we want to have a processor that's similar to our graphics design workstation, a high-end processor. We want to have our specialized video and audio cards. We want to have the maximum amount of RAM that we can get in that case on that motherboard. We want to have maximum RAM in that computer. And we also want to have a large and fast hard drive, possibly separate solid state and hard disk drive if necessary. And then finally, we want to have our dual displays so that we get the maximum use of our video card and we're able to work on a lot of things at a lot of different times at the same time. And we can maximize our efforts with our audio and visual computer.